B Centauri b, the impossible planet that redefines our understanding of the cosmos. There's nothing in the universe quite so humbling as discovering that everything we thought was impossible is happening right before our eyes. In the ever-expanding gallery of cosmic wonders, B Centauri b has etched its place as one of the most mind-bending, awe-inspiring, and scientifically perplexing discoveries to date. It's a planet that should not exist, and yet it does. This isn't just another distant world added to our ever-growing list of exoplanets. This is a planet that challenges everything we thought we knew about planetary formation, survival, and the very limits of what's possible in the hostile expanses of space. Shooting star, welcome to B Centauri b, the giant among giants. In the grand symphony of the cosmos, B Centauri b plays a tune that defies the rules of harmony. Discovered in 2021 by an international team using the Very Large Telescope (VLT) at the European Southern Observatory in Chile, this gas giant is over 10 times more massive than Jupiter, the behemoth of our own solar system. That already makes it the most massive planet ever directly observed. But it's not just its size that's blowing astronomers' minds, it's where it lives. This planet doesn't orbit a calm yellow star like our Sun. Instead, it circles a pair of ferocious B-type stars, stellar monsters known for their intense radiation, blistering ultraviolet emissions, and scorching stellar winds. These stars are so energetic and luminous that planet formation around them was considered impossible, until B Centauri b proved otherwise. Comet, a planet in a death zone. Let's put this in context. B-type stars are hot, massive, and short-lived. They burn at temperatures up to 30,000 Kelvin, shine tens of thousands of times brighter than our Sun, and die young, often in dramatic supernovae that scatter their remains across space. Most scientists believe that these stars disrupted or destroyed any surrounding protoplanetary material long before planets could form. That's because their intense radiation and powerful stellar winds rapidly strip away the gas and dust disks that planets typically form from. In other words, B Centauri b's birthplace is an interstellar war zone, a realm of searing radiation, roaring stellar winds, and gravitational chaos. And yet, here it is. DNA. How did B Centauri b form? The discovery of B Centauri b forced scientists to confront a question many thought they'd already answered. How do planets form? The dominant theory, called core accretion, suggests that small dust particles collide and stick together, slowly building up into planetesimals, which gather more material until they become full-fledged planets. But in an environment like B Centauri, this process shouldn't stand a chance. So how did B Centauri b form? Scientists now think it might be the product of an alternative and far more dramatic process known as disk instability. In this scenario, the protoplanetary disk doesn't build up planets piece by piece. Instead, massive clumps of gas and dust collapse quickly under their own gravity, forming planet-sized bodies in a rapid, violent process. In other words, B Centauri b may have formed in a flash, born fully grown in the chaotic nursery of a hostile star system. This isn't just a tweak to existing theories. It could represent a paradigm shift in our understanding of planet formation in extreme environments. Milky Way, the orbit of a survivor. There's another twist to the tale, B Centauri b's orbit. This massive planet doesn't skim close to its searing stars like Mercury or Venus. Instead, it orbits at an enormous distance, about 560 astronomical units, AU, from its parent stars. For comparison, Pluto orbits the Sun at about 39 Australian dollars. This vast distance might be the secret to its survival. Far from the lethal embrace of its parent stars, B Centauri b is beyond the reach of their most intense radiation, allowing it to maintain its atmosphere and stability. It's as if the planet was strategically exiled to a safe distance, far enough to exist, but close enough to remain part of the system. Telescope, discovered by the Very Large Telescope. This cosmic anomaly was spotted by the Very Large Telescope (VLT) in Chile's Atacama Desert, one of the most advanced astronomical observatories in the world. Using instruments that detect infrared light, astronomers were able to observe the faint heat signatures of distant planets. The fact that B Centauri b was detected directly, rather than inferred through indirect methods like transit or radial velocity, makes the discovery all the more spectacular. This planet wasn't just a line on a graph, it was a real, visible object, orbiting impossibly within a system no one expected it to survive in. Shooting star extreme worlds, the universe's wild side. B Centauri b is far from alone in its strangeness. The known universe is filled with exoplanets that defy logic, shatter records, and push the boundaries of our understanding. Cloud with Rain, HD 189733b, the Blue Hell. A gas giant where silicate glass rains sideways in winds over 7,000 kilometers per hour. Its atmosphere is so hot and dense that it shines a deep, eerie blue. Beautiful, yes, but unimaginably hostile. Kepler 10c, the Godzilla of Earths. A rocky planet 17 times more massive than Earth, defying all previous models of rocky planet formation. It's so massive and dense that it shouldn't exist as a solid world. Yet it does. Fire Wasp 12b, the melting giant. Orbiting its star in less than a day, this hot Jupiter is so close to its host that it's being ripped apart by tidal forces, slowly spiraling toward destruction. Snowflake OGLE 2005 BLG 390 LB, the Frozen Wanderer. One of the coldest planets ever discovered. It sits in lonely orbit at minus 220 degrees Celsius, a frozen world in permanent twilight. Ring J1407b, the Super Saturn. Imagine a ring system 200 times larger than Saturn's, so wide that if placed in our solar system, its rings would be visible from Earth with the naked eye. These worlds are not just numbers or data points. They are testaments to the infinite creativity of the cosmos, revealing that the universe is wilder and more diverse than even our most ambitious science fiction. Glowing star, is B Centauri b the largest planet in the universe? With a mass over 10 times that of Jupiter, B Centauri b is currently among the largest directly observed exoplanets. But is it the biggest of all? That's still an open question. Our catalog of exoplanets has now exceeded 5,000 confirmed worlds, but that's just the tip of the cosmic iceberg. Estimates suggest there could be trillions of planets in our galaxy alone, and we're only just beginning to find them. Many giant planets remain undetected, especially those too distant, faint, or obscured by their star's glare. As new telescopes like the James Webb Space Telescope JWST and the Nancy Grace Roman Space Telescope come online, we'll likely uncover more giants and more oddities. Compass, is there a link to Alpha Centauri? The name might sound familiar, B Centauri, Alpha Centauri, Beta Centauri, and that's no coincidence. These star systems are all located in the Centaurus constellation, but they are not physically close to one another. For instance, Alpha Centauri is the closest star system to Earth, just 4.3 light-years away, and home to Proxima Centauri, which has its own planetary system, including a possibly habitable world. Beta Centauri, also known as Hadar, is about 390 light-years away. B Centauri is farther still, and significantly more massive and energetic than either of the others. The similar names are due to their positions within the same constellation, not their physical proximity or relation. Milky Way conclusion. The universe is wilder than we imagined. The discovery of B Centauri b reminds us of a fundamental truth. We know less than we think we do. The universe doesn't play by our rules. Just when we think we've figured it out, it throws a curveball, a giant planet orbiting two deadly stars, far beyond where such a planet should ever have formed. It's a humbling reminder that our theories must bend to reality, not the other way around. As we peer deeper into the night, powered by ever stronger instruments and ever bolder curiosity, we'll find more B Centauri b's, more exceptions to the rule, more impossible worlds that turn impossibility into fact. So keep looking up, because out there, in the infinite canvas of stars, the cosmos is still writing its greatest stories, and we're just beginning to read them.